So now let's take a look at structural theories of pattern recognition. And structural theory incorporates how the features fit together to form an object. So not just what features there are, but how they sort of combine. Here's an example of these Gestalt principles. They are very important in helping guide how we put pieces together, how we view a form or a shape, how we group the different elements of those. And that's part of what's important for the structural theories, is that it's not, you're not looking at all of the elements or all of the features. You are looking at them kind of holistically according to these Gestalt principles. So what do you see in this picture? How does our perception of this image rely on Gestalt laws of grouping? So first off, you might see a Dalmatian here. I'm going to try and do a general outline here of the dog. Kind of lose its leg over here. So roughly like that. So similarity plays a role. We group the shapes that are more similar, like the ones here inside the dog's body, together based on their similar shape, versus this area here where we group this cluster together and this cluster, right? And here, for example, these shapes, they're more elongated, and as a result they get grouped together. So you can see that the shapes here are different from the ones in here. So we see similarity, proximity, shapes that are close together get grouped together. Continuation, we may form a line, for example, here, connecting the dog's leg together. So even though it's not continuous, we may continue that imaginary line along there. And then a good figure, that we will tend to group items together to create one shape as opposed to many distinctive shapes. So we use the simplest configuration possible. So what about three-dimensional figures? Here are three different pictures of cubes. They are just line drawings. It's much simpler to describe each shape as a three-dimensional object, cube, rather than focus on the individual lines and all of the different features and their combinations. So, you know, this has this orientation of line, this orientation, this one here. Does it continue or does it stop at this point? There's all these different details that we have to take into account if we're focusing on just the features. And so to sort of deal with that complexity, Biederman developed this recognition by components theory, sometimes abbreviated RBC. And the idea is that we recognize objects by the component parts that sort of form their shapes. And these component parts are called geons. They are geometric icons, and they are three-dimensional shapes. So that it's kind of like a series of puzzle pieces that fit together and sort of create objects out of their shapes. So here we have a cylinder, this sort of cone-like shape, and this little triangular, you know, sort of pyramidal shape. And so the idea is that we perceive these objects. Notice that we can look at them from different points of view. From here, right? From the left, sort of head on, and then here a little more from another angle. And so we can view these objects from slightly different angles and still recognize them as the same object. That, by the way, is called viewpoint invariance, that we can recognize the object or a geon even when the observer changes their point of view. So if we're standing around, kind of walking around a car, looking at it from these different perspectives, different locations, it's going to all look the same. And so here's an example of 5 objects constructed from just 3 different geons. Here we can see that if we're looking at this row, we have this object looks kind of like a wastebasket, right? But this particular geon, and here it's a different geon. Entirely. Whereas here it's the same geon, but with a slight variation. And it turns out that when it's a totally different geon, people can distinguish between them really easily. When it's the same geon, just with a slight variation, then it's a little bit harder for people to distinguish them. That supports the idea that geons are very helpful in recognizing objects. When drawings of different objects were presented for 100 milliseconds, so pretty quick, 1/10 of a second, subjects correctly named 70% of the objects if the contours were deleted at mid-segments, not the corners. If the contours were deleted at the vertices or the corners, subjects correctly named fewer than 50% of the objects. So here we can see that we are still able to sort of fill in and recognize the shape of this cup very easily, even when most of the object is not visible. Here, without those corners, we're not able to do that. And here again, we can see that the object on the left is very hard to identify, whereas here, because we do have the ability to determine the geons, because we're able to see the curved shape and kind of connect them like that, we are able to recognize this object as the flashlight. How about this object? Recognition by components theory says that geons should be perceived from any angle or point of view. This is called view invariance. So some people say this kind of looks like a knob, right? It's hard to say. Let's look at it from a different angle. Oh, tea kettle. So this object, when viewed from directly above, looks kind of like this. And so we do not always have view invariance. That's one little problem with recognition by components. It most of the time does demonstrate view invariance, but it is true that looking at something from a more common viewpoint makes the object easier to identify. So recognition by components kind of works like this. You look at the object, you break it apart into its geons, which you are very quickly and easily able to identify. You combine the geons together to identify the objects, and ta-da, the object is identified. But how can geons help us distinguish between similar models of cars, for example, that might all have very similar shape, might have all the same geons, or two different animals like a zebra and a horse that have pretty much the same geons as well? Oh, it does not do well with that, right? It does not do a good job in that sense. So geons and the relations between them will not always allow us to distinguish many real objects. For example, a pear and an apple are easily distinguished by people, but they lack the corners and edges needed for RBC theory to recognize that they are different. However, Biederman has argued that RBC theory is the preferred mode of human object recognition, with a secondary process handling objects that are not distinguishable by their geons. So it's like the easier kind of go-to method.